Welcome back. I am Devabrata Goswami and you are watching Chemistry 11. Before the break, I asked you what role does boron play in controlling diseases. Let me tell you. Osteoporosis and osteoarthritis are diseases of the bone, and boron plays a very important role in their management. Boron, although present only in minute amounts, has been linked to significant improvements in both osteoporosis and osteoarthritis. The process involved are not yet completely understood, but it is likely that they involve boron's effect on both vitamin D and estrogen. Boron is particularly important for the activation of vitamin D, which controls the absorption and utilization of calcium in the body. After studying the structure and uses of boron, let us take a look at the physical properties of boron. We have already discussed the anomalous behavior of some p-block elements. But what exactly does that mean in terms of boron? Boron is a non-metal with a high melting point of 2453 Kelvin, whereas all the other members of the group, that is aluminium, gallium, indium and thallium, are soft metals. Boron is a poor conductor of electricity, whereas other metals of the group are good conductors. Well, I hope you got that. Let's see if a viewer has a doubt.
My question is, does boron differ from the rest of the elements of the group in its chemical properties?
That's an interesting question. Yes, boron also differs from the rest of the elements of the group in its chemical behavior. This is because of its small size, high ionization energy, and absence of vacant d orbitals. Let us get this straight. The first property of boron is covalency. In its compounds, boron exhibits a maximum covalency of 4. You know that covalency is the number of electron pairs an atom can share with other atoms. In this case, there is an absence of vacant d orbitals in boron. Atomic number of boron is 5. Hence, its electronic configuration is 1s2, 2s2, 2p1. Thus, it can form compounds like boron trifluoride easily. Boron trifluoride easily reacts with Lewis bases such as ammonia to complete the octet around boron. It is due to absence of d orbitals that the maximum covalency of boron is 4. In its crystalline structure, boron is unreactive to most chemical reagents at ordinary temperature. It reacts only with strong oxidizing agents such as mixture of concentrated nitric acid and concentrated sulfuric acid to form boric acid and nitrogen dioxide. However, it combines with metals at very high temperatures to form borides, which are generally hard solids with high melting points. Boron also combines with oxygen in the air at high temperature to form boron trioxide. Till now, we have studied that boron differs from other elements of group 13. But let's now take a look at the similarities. Boron closely resembles silicon, the second element of group 14. This property is known as diagonal relationship. Recall that the similarity in properties of elements present diagonally is called diagonal relationship. Let's see what these similarities are. Both boron and silicon are semiconductors. The hydrides of boron and silicon are gaseous, readily hydrolyzed and spontaneously inflammable. The halides of boron and silicon hydrolyze readily and vigorously. Both boron oxide and silicon oxide are acidic and dissolve in alkali solutions to form borates and silicates respectively. That was all about the chemical properties of boron. I have a question for you. Which isotope of boron has the ability to absorb neutrons? And the answer is boron 10. It has high ability to absorb neutrons and therefore is used in nuclear reactors as control rods. And that brings us to the end of the theory in this session. I'll take a short break now, but stay tuned because after the break will be your chance to test yourself in exam decoded. Welcome back. For those who have just tuned in, you are watching chemistry. And today we are discussing the P block elements. It's time for exam decoded, but before I put you through the rapid fire round, let us recap what we have learned today. The first member of each group of P block differs from the rest of the elements of their respective groups. The first element of group 13, boron, exists in 4 allotropic forms. All the 4 allotropic forms of boron contain icosahedral units with boron atoms at all the 12 corners. Boron differs from other elements of group 13 but shows a diagonal relationship with silicon. That's what we have learned today. Now on to exam decoded. Welcome to exam decoded, where I will give you the ideal configuration to crack your exams. You know, answering exam questions doesn't always have to be stressful. It can also be an invigorating challenge, a lot like our rapid fire round. Let's go over the rules. This round has 5 questions for 1 mark each. You will get not more than 5 seconds for each answer. Track your scores carefully and I will tell you what they mean later. Your first question is, what is the maximum covalency of boron? A 4, B 6, C 8, D 2. Correct answer is A 4. Coming up, question number 2. Which of these forms p-pi multiple bonds? A aluminium, B carbon, C gallium, D none. Correct answer is B carbon. Time for next question. Boron has a very high melting point. True or false? Yes, this is true. Fourth question is, boron shows diagonal relationship with A aluminium, B gallium, C silicon, D none of these. And the answer is C silicon. Now the last question. The first element of each group of P block does not have vacant d orbitals in their valence shell. True or false? That's true. And with that, we end the rapid fire round. Time now to see how you have fared. If you have got all 5 answers right, then you are a high flyer and this is definitely your strong subject. If you have scored 4 or 3, then you are an achiever. You are doing well, but a bit more practice is needed. If you have scored less than 3, then you are a learner who must keep studying hard to master this topic. But no matter how you did in our rapid fire round, do log on to www.topperlearning.com for many more tests and questions. This topic comes under the unit the P block elements and has a weightage of 7 marks. So it is critical from examination point of view. Short answer questions of 1 or 2 marks testing your knowledge ability and conceptual ability are usually asked from this topic. Well, when you are writing your exams, presentation is just as important as knowledge. So, let's take a look at a question that you can be asked in your exams and see how you should ideally answer it. Take a look so that you don't lose unnecessary marks. This question can come in your exams for 2 marks. Boron is unable to form BF6 3- ion. Explain. And the ideal answer is, in BF6 3- ion, the covalency of boron is 6, but boron has a maximum covalency of 4. Hence, boron cannot exhibit a covalency greater than 4. So, BF6 3- ion cannot exist. This statement will fetch you 1 mark. The reason for this is that boron has an electronic configuration of 1s2, 2s2, 2p1, and it does not have any vacant d orbitals to expand its octet. This statement will fetch you another mark. I hope you found today's episode interesting and informative. Well, that's it for today. But don't take your thinking cap off yet. I want you to seek the answer to a question. Tell me, what is the impurity present in blue diamonds? You could seek the answer at www.topperlearning.com or keep thinking. This is Devabrata wishing you a stress-free preparation. The first rule of driving, you should know how to use your brakes. But what are these brakes made of? Well, they are made up of an important boron compound, boron carbide, which is extremely hard compared to the other elements of the group. Why is it so? Keep thinking. Hi everybody, this is Devabrata Goswami. Welcome to an interesting episode of chemistry. Today we will be talking about boron, which belongs to group 13 of P block. It is an element that is very different from the other elements of the same group. In this episode, we will take a look at the anomalous behavior of the first element of each group belonging to P block. Then we will study about physical and chemical properties of boron. Finally, we shall wind up with important questions in the exam decoded section. So let's begin. I have been saying that the first elements of the groups in P block show anomalous behavior. But what do I mean by that? The first member of each group of the P block, that is boron, carbon, nitrogen, oxygen, and fluorine, differ from the rest of the elements of their corresponding group. This behavior is known as anomalous behavior. Now, why do these elements behave differently from the other elements of their groups? The first reason is their extremely small size in comparison to the other members of their group. The second reason is the absence of vacant d orbitals in their valence shell. For example, boron, the first element of group 13, has an electronic configuration of 1s2, 2s2, 2p1. As you can see, d orbitals are absent. All the other members of its group have empty d orbitals. The presence of these d orbitals influences the chemistry of the heavier elements of p block in a number of ways. The combined effect of size and absence of d orbitals influences the ability of the first element of each group to form pi bonds. We already know that the pi bonds are formed by the sidewise overlap of atomic orbitals. Because of extremely small size of the first element of each group, they are able to approach each other closely. As a result, effective sideways overlap of their p orbitals can occur and these atoms form pi bonds. Therefore, carbon, nitrogen and oxygen are able to form p-pi multiple bonds along with single bond. On the other hand, for other elements of p block which are larger in size, pi overlap between their p orbitals is relatively ineffective. So, pi bonds formed by large atoms are relatively weak. Therefore, the heavier elements do not show any tendency to form p-pi bonds. They can, however, form multiple bonds by using their d orbitals, that is, d-pi p-pi, d-pi d-pi bonds. Now, let us look a little more closely at boron, which is denoted by letter B. Other elements being aluminium, gallium, indium and thallium. These elements are denoted by letters Al, Ga, In and Tl respectively. Boron has a distinct appearance. It appears black-brown in color. Ironically, the word boron comes from an Arabic word meaning white. This is probably because borax, which is the most common source of boron, is white. Boron has a very high melting point. This is due to unusual crystal structure. It exists as 4 allotropic forms. Recall that allotropes are forms of an element with different physical and chemical properties. All the 4 allotropic forms of boron contain icosahedral units with boron atoms at all the 12 corners. An icosahedron is a regular shape with 12 corners and 20 faces. In each icosahedron unit, each boron is bonded to 5 other boron atoms which are present at equivalent distance of 1.77 angstrom. The difference between all the 4 allotropic forms arises in the way the icosahedron